Hello everyone, welcome. So up next we have Emin Martinian, who will be sharing tips and tricks for JSON Web Tokens. So let us give a warm welcome to Emin.
Thank you very much for that applause, and thanks for coming to my talk about tips, tricks, and reasons for JSON Web Tokens. Okay, briefly speaking, JSON Web Tokens are used for authentication and authorization. For example, if you have a front-end client, like a single-page web app or an application on your phone, and you want to communicate with a back-end server or an API server, they are compact, they're standardized, they're secure, and they're customizable, and they're a great stateless alternative to cookies and sessions. Also, these slides and any of the sample code mentioned is on GitHub, so feel free to grab it from there. Okay, so let's start with the main question. Why would you want to use a JWT? Why not use a cookie or a session or some other kind of technology? Why JWTs? Well, imagine if you have an app and you've got a lot of features, so you've got lots of users, it means you need lots of servers, and so you need lots of engineers, so that's great. And maybe you have load balancing, you have payments, you have user profiles, maybe there's some personally identifiable information, you've got a database to keep track of all that. Fantastic. You have local workers, remote workers, international workers, consultants. How are you going to manage security for this app? And security can be a really big headache because you can't give everyone access to everything. You can't have everyone in the company accessing the payment database, or you can't have everyone accessing the secrets or the user profiles or things like that. And thinking about security will also cause you a lot of other headaches. Like when you're deploying your application servers, you need to keep track of what secrets need to go along in there. How do you manage the timing of the deployments? How do you scale your application? Could you have a serverless or a stateless system? And all that leads to why you might want a JWT. Okay, so with a JWT, you can separate the concept of authentication from validation. So you can have an authentication server, which requires the high security. It's the thing that has the secret keys. It's probably a big, beefy server that can do a lot of processing. Probably you only have one, maybe you have a couple of them. You have to keep them in sync. But you separate out the complexity of managing the security and all of that into this one authentication server, or maybe a few. And then for your application servers, they're much easier to manage. All they're going to do is validation. They're not going to have secrets, at least not for authentication. They're not going to have secrets. They're just going to have public keys. Because they don't have secrets, all of your engineers can access them. All of your engineers can see the debug logs. Basically, it makes your life a lot simpler. Okay, so how's this going to work? So you have a client, and think of the client as your single-page web app or the application on your phone or something like that. The client is going to want to authenticate. So a user types in their username and password, or maybe they do OAuth like we saw in the talk before, or maybe they pay with a credit card. So the client connects to the authentication server, provides that information to authenticate itself. And then the authentication server sends back a JWT. And the JWT is a JSON Web Token. It's going to have a header and a payload, sometimes called claims, and a cryptographic signature. And the cryptographic signature is something that could only be produced by the authentication server. And so then when that client wants to get a service, it's going to send that token to the application server. The application server is going to validate that token. That is, make sure it's a token that was produced only by the authentication server. It's not a fake token. And then if that token validates, then the application server is going to provide service. And we'll get into all the details of it. But the key point from this slide is it lets you separate your system into the highly secure authentication server and then the application servers, which can be stateless, have public keys, be distributed, and so on. So again, the authentication server has the secrets. It needs security. It's a maintenance nightmare. The application server is public keys, low security. They're easier to deploy. They can be serverless. You can run them on AWS Lambda, Kubernetes, what have you. You can allow all your engineers to access the debug logs and so on. Okay, so what does a JWT look like? At a high level, they're just a base 64 encoded header, payload, and signature connected by dots. So the header is going to have a number of fields. The most important is probably the alg, or algorithm field, which is going to tell you what kind of cryptographic algorithm you're using to secure the key. And in this example, I'm going to use EDDSA. You could use RSA. You could use a whole lot of different stuff. I'll mention that a little bit later. And then there's going to be a type field which says JWT. You can have lots of other things in there, but that's the basic idea. Essentially, the header tells you what this is and how to verify it. The more interesting part is going to be the payload, which is going to have essentially a dictionary with what are called claims or key value pairs. There's some of these that are standardized, like sub is the subject. Usually this is a username, an email, something like that. You can put your own arbitrary data into the payload, like you could put a name, which is the user's legal name or the name of something else. And then there's some other standardized fields like IAT is issued at, which tells you when the token was issued. You can have things about expiration, lifecycle management, and so on, which we'll get into. Then there's a signature. This is a base64 encoded signature, and this is a cryptographic signature, which ideally only the authentication server could produce, and nobody else could produce. And the signature validates the payload, so you know the payload hasn't been tampered with. And then the final encoded JWT that you'll see in your HTTP headers is going to be the base64 encoded versions of all these concatenated with dots. And then finally, if you want to reproduce this example using the code on GitHub, this was signed using EDDSA with the following secret key. So the secret key is also nice and compact. One brief thing to mention while we're on the subject, some of the signature algorithms will give you a deterministic key. EDDSA gives you a deterministic key. Some of the others will give you non-deterministic keys. So just be aware of that if you're trying to reproduce someone's example. Otherwise, you can get pretty confused. Okay, so some of the more interesting JWT fields are subject, we talked about that. It's the username, the email, something like that. IAT is issued at, which is when the token was issued. So you can check, is this a recent token? Is it an old token? Is it a stale token? You can force how recent you want your tokens to be. There's EXP, which is expiry, and NBF, which is not before. So you can use these to control the token lifecycle. Okay, so this is PyCon, so let's talk about how you could use JSON in Python. So in this example, we're just going to use Flask. You could do Fast API, you could do Django, you could do whatever service you want. And one of the really nice things about JWTs is there's a lot of libraries that support JWTs, and you can write your own tools pretty easily, and you can compose them with decorators. So in this example, we're going to have an urgent support route in our application or our website, and we're going to start with the built-in Flask app.route decorator. And so this just says how do you get to the service. Then we're going to have our own custom decorator called @requires_JWT. And this is just going to check that we've got a valid JWT, and if you do, you get continue. If not, you're going to get rejected. Next, we have JWT claims. And in this decorator, we're going to say, we want the claims to have something that says the user paid for support. Because if we're going to provide urgent support, we want to make sure they've paid for that. Next, we can have another kind of decorator, here JWT_IAT. And here we're going to check that IAT field to make sure they paid for support recently. So they paid within 24 hours or something. And then if all of those pass, then we'll provide the service in the application server. Again, the point here is you can very easily write Python code to compose these decorators to get the kind of validation you want in your application server. Okay, so how would we write an example of the requires JWT decorator? Oh, I should mention, if you're not familiar with decorators, they're one of the coolest features of Python, in my opinion. You write a function which takes in another function, modifies it, and gives you back the modified function. So you can do a lot of really neat things, and you can also make your code super confusing. So great feature. So in this case, we've got our decorator requires JWT. It's going to take in a function, which is a Flask route that we're going to protect. Then we're going to define the decorated function. And the decorated function is going to first look in the header for your standard authorization bearer token. It's going to pull that token out. If that token's not there, we're going to return a 401 error, say you're missing the token. Pretty obvious. Then if the token is there, we're going to call JWT decode. So this is provided by the PyJWT library. We're going to give it the token. We're going to tell it a list of algorithms we accept. In this case, we're going to say EDDSA. In principle, we could provide we could allow other algorithms like RSA or something like that. Here, just EDDSA. And then we're going to give it the key. And this is the public key. Maybe you load this from an environment variable, maybe from a file, maybe it's in your source code. Again, it's a public key, so you don't really have to worry too much about security. That's fantastic. Then the JWT decode is going to verify that the token is protected by the signature, that the signature is valid, the claims are match. And if all that's good, the decoded token is going to get put into the Flask thread context G. And then we'll return the function, execute the function. Great. Let's look at a little more interesting decorator you could create. So this is going to be JWT claims. So we want everything to make sure that it has a valid JWT. Great, but some of the routes we're going to want to require more permissions or different kind of permission structure. And again, we can do that really nicely with decorators. So here, a JWT claims decorator is going to take in a claims list, which is things we want to be in the payload if we're going to allow access to this route. So we're going to define a function make decorator, then we're going to have a wrapped decorated function. That's just going to look in the claims list, which we pull out of the g.decoded JWT, which we created in the previous step. That is, we put that decoded JWT into g.decoded JWT, so we don't have to do an potentially expensive cryptographic check anymore. We just look at the decoded JWT. We look in that claims list, see if there's something that says paid support in a previous example or whatever you like. If there's any missing claims, we return a 401 error. Otherwise, we execute the function. Great. So the point about the decorators is it's a really nice way to take your JWT and build whatever kind of security features or architecture or permissions you want. So let's do something a little bit more interesting than just letting you in or out, which is the use case of a proxy. So imagine you want some user, Alice, to be able to take some action for Bob. Maybe Alice wants to be able to create some files for Bob or read some files for Bob or do some processing, file some issues, or whatever. Now, you definitely don't want to have Bob give Alice his password. Even though there's lots of commercial bank APIs which actually ask you to give your password to some other system, that's obviously not best practice. So how can we do something better than having Bob give Alice his password? Well, we can have a system where in the claims, we have the subject, that is sub, be Alice, because she's going to be the person doing the actions. But we can have another field that says proxy Bob. You could also say effective user Bob, but proxy fits nicer on the slide. Okay, so Alice is going to send a request to act for Bob. And here's how we would implement it with a decorator. So we're going to have our Flask app.route decorator. This is say a route to create an issue. We're going to have a requires JWT to make sure we've got a valid JWT. And then when we decide which user we're going to create the issue for, we're going to look into that decoded JWT, and we're going to get proxy if it exists in the claims. So if proxy is there, for example, Bob, then the effective user is going to be Bob. And if that proxy field isn't there, then we'll fall back and get the subject field, and we'll have Alice be the effective user. Then maybe we'll have a message, and we'll create the issue, and everything is great. And if you want to, you could also look for the real user in the subject field. And if that real user is not the same as the effective user, you can have a message or take some other action. So the key point here is that we've got a somewhat complicated feature that is a proxy use case where one user acts for another. But it's really easy to implement with JWTs because you put that information into the claims, and then you have your code check, okay, we know who the real user is, which is Alice who's taking the action, and we know who the effective user is. Very nice implementation. Really easy to do with JWTs. Okay, so JWTs are great. They've got cryptographic signatures, so they're secure. They're very flexible. You can put whatever you want in them. They're standardized, so you'll find libraries in many different languages which will create JWTs, parse JWTs, validate JWTs. So they sound fantastic, but there's a few caveats to be careful about. So probably the number one caveat is you want to beware of using the header fields to check the signature. That is, you don't want to trust the alg field, or at the very least, you want to limit the possibilities. So in all these examples that I've shown you, I've had algorithm equals edDSA. So when I'm decoding the JWT to validate it, I'm only allowing edDSA. But maybe for some reason, maybe you're using edDSA and then you decide you like RSA or vice versa. Maybe you want to allow multiple algorithms. That's fine, you just want to whitelist them. You don't ever just want to look at the algorithm field from the header and trust that blindly. And I'll show you why in a little bit. There's other fields which are really nice to have. KID, which is key ID, JKU, JWK, etc. These basically tell you where you would go and get that public key. And if you've got a more complicated application, it's nice for the token to tell you where to look for the public key. Very useful, but again, you don't want to trust the header because the header tells you how to check the signature for the payload, but there's no signature for the header. So anything you see in the header, you want to validate against the whitelist. Only allow the header to choose from something you've pre-specified beforehand. And I'll show you a little more about this later. The other main caveat that I think is helpful to keep in mind and trips up a lot of people is you don't want to simulate sessions with JWTs. That is, in the old days, Cookies or sessions were a typical way to do authentication. They're nice, they have a lot of good features. They're not stateless, so they don't work so well in situations where you want scaling. JWTs have a lot of nice features, but they're not sessions, so be mindful of that. And I'll show you an access refresh token flow to solve some of the issues in simulating sessions. Okay, so let's get into an example of an attack. So imagine you've got an application or you've got a JWT and you want to think about attacking it. So if a whitelist is used, and most libraries, by the way, will encourage you to use whitelists or they'll force you to use them in various ways. So I don't want to overly scare you, but I want to give you some sense of why these whitelists are important. Okay, so you've got a JWT. It says algorithm DSA, and it tells you a URL for where to get the public key. So good.com/pk.json. Great. Now, if you didn't have a whitelist, what an attacker could do is just replace that JKU and have it point to a public key that they control. So by pointing to a public key at bad.com, they could put in a public key where they have the secret key, and so they can generate a valid signature for some token that they've made up. And then your JWT decode is going to say, you know, the signature matches the payload, everything's great. That's why you don't want to just blindly trust whatever you see in the header and the JKU. You only want it to choose from a list of things that you've decided is valid. Again, don't trust the header, validate against the whitelist. Let me give you a slightly more interesting example here. So, okay, let's say you're like, okay, JKU, I get it, you're choosing the keys. You know, you can't let anyone just tell you which keys to use, you gotta whitelist it. But what about the algorithm? Like, why do I need to whitelist the algorithm? You know, these are all cryptographically secure algorithms. You know, why don't I let the, whoever's sending the token choose that? Well, one example is they could switch from EDDSA to HS256. So EDDSA is what's called public key cryptography. It's asymmetric cryptography. There's a different secret key versus public key. With something like HS256, it's a symmetric encryption algorithm where the public key and the private key are exactly the same thing. So even if you stick with the JKU to be good.com/pk.json, if you don't whitelist the algorithm, if you let an attacker change the algorithm in the header, they could change it to HS256. Then they have the secret key because the secret key and the public key are the same thing in HS256. So key point here, don't trust the header, validate against the whitelist, you'll be fine. Again, I don't want to make this overly scary. JWT libraries are pretty good about this. Any kind of authentication framework you use, you know, Auth0, Okta, et cetera, they'll probably manage this for you. But it's a good thing to be aware of why you're doing this and what the purpose of it is. Okay, let's talk about another interesting issue, which is revocation and access control. So one of the features of JWTs is you can use them and have a completely stateless, serverless application server. So what happens then if your application server is completely stateless, it doesn't remember any state, and somebody steals your phone or somebody steals your computer? You say, okay, well, I just want to do a remote logout of all systems. So log out of all my JWTs. But again, JWTs aren't sessions, so there's no notion of logout. If someone's stolen your computer and they've got that JWT and the application servers are all stateless, they can keep using your JWT to impersonate you and get service from the application servers. And that's a problem. So you think, well, okay, well, how do I solve this? You might think, well, let me just be able to send a message to the application server saying, you know, this token was stolen, don't honor this token anymore. You could do that, but that defeats the whole purpose of having stateless, serverless, scalable application servers. So you don't want to do it that way. You don't want to try and simulate the concept of a session with the application server. Instead, what you want to do is you want to use the fundamental theorem of software engineering, which says any problem in software engineering can be solved with one more level of indirection. And so the indirection in this case is instead of using one token, we use two tokens. We use a refresh token and an access token. The refresh token is something that has a long expiry, and it's used to get an access token without an additional credential check. And then the access token has a very short expiry, which is used to get service. So let me show you what this looks like. So first we get the refresh token, and this is just a standard thing you've seen before and that I showed you in the beginning, which is the client wants to log into the authentication server. They type in their password, they do the multi-factor with their phone, maybe they do OAuth, whatever. Then the server sends back the refresh token, which has a long expiration time. Maybe an hour, maybe a day, maybe a week, maybe a month, something long. Then the client wants to get some service from the application server. What it does is it sends the refresh token back to the authentication server. The authentication server validates it and immediately sends back an access token, which has a short lifetime, 30 seconds, maybe a minute. A couple of key points here. The client you should think of not as the user, but as the phone application or a single page web app or something like that. So there's no like typing in your login and password on this step. You've already typed in your login, password, shown your credit card, done the OAuth, your MFA, all that stuff. You do in the first step, you do it once, maybe once a week, once a month or something to get your refresh token. Once you've got your refresh token, that's stored by your phone app, your single page web app, etc. And your app sends that refresh token to the authentication server to get an access token. It then sends the access token to the app server to request whatever service. So this part is just like before. The application server validates the signature, and then it provides service. So this is where the Flask decorators and so on would come in. Okay, so why are we doing this extra level of indirection? Well, the answer is, imagine that you lose your phone, you lose your token, you lose your computer. Even worse, maybe one of the application servers is compromised, some attacker gets access to it for a few minutes, something like that. So in that case, you can't, remember, the application servers are stateless, so you can't tell them anything. But what you can do is you can send a message to the authentication server to say, cancel that refresh token. You could keep track of that particular refresh token, or you could say, for this particular user, cancel all their refresh tokens, require fresh login, etc. And the purpose of that is the next time the client wants service, it sends the refresh token to the authentication server, says, please give me an access token. The authentication server says, no, sorry, your refresh token has expired, been canceled, there's fraud, whatever, you need to log in, get a new refresh token. The user does that, authenticates themselves, and then they can continue. The point here is because the access token is very short-lived, if something is compromised, it's only the access token that can be compromised, and that's going to last 30 seconds or a minute. So you have a very small window where the attacker can do something. After that, the client can no longer get access tokens to send until they re-authenticate, and any access tokens that have been compromised are going to expire really quickly. And that's how you get, again, it's not a session, but it's how you manage the issue of revoking a token or if there's fraud or something is stolen. Okay, so we've talked about separating authentication from validation, and that gives you a lot of nice features. It's easier to manage keys. You have scalable, serverless, stateless application servers. It's fantastic. But we can even go a step further, which is we can use middleware to verify the signature. And we can separate the validation from the parsing. So imagine you've got a request coming in. It's got your JWT header. And imagine your application server has an Nginx front end as the web server. You can do the validation of that JWT in the Nginx server, stick the decoded JWT in the header, then pass that along to your Flask server. Your Flask server or Django or whatever Python code you have could then parse the JWT claims, do further authentication, and so on. So why would you want to do this? Well, there's a couple of reasons. Maybe you write some super fast authentication code and you want to stick it as middleware in front of your Flask server or your Python server. That's a nice reason. Maybe you have a bunch of static routes and you want those static routes also protected because by default, you're not going to be checking JWTs for a static route because usually don't apply decorators to static routes. You could, but people tend not to do it that way. With this middleware approach, even your static routes are protected. Or maybe there's a number of things behind your Nginx server. Some of them, the best parts are obviously going to be your Python server, but maybe there's some other microservices in there that you also want to protect with your JWT, and you can do that with a middleware. The best reason I can tell you to do this is actually another security reason, which is imagine you're integrating with a bank or a credit card company, and they want to do a security audit to make sure your code is secure. You say, great, I'm using Python, I'm using JWTs, they're standardized, it's awesome, I use these decorators, I can just show you where all the decorators are applied, and it's great. So the bank is probably not going to be happy with that. And the bank is never going to be happy with dealing with you to begin with, but they're especially going to be unhappy with having to look over a bunch of Python code. Because they'll say like, well, what if you write another Python function? Or what if you have a junior engineer and he forgets to put on that decorator? Or what if I don't want to read 100 different Python files? So if you use middleware, you can say like, look, we're using JWTs, they're great, but we're also using middleware. So there's just this one place where you can look at my middleware to see that anything that comes into my system is going to get parsed by my middleware. It's going to have a valid JWT, and nothing will get in unless you see that. And They still won't be happy, but they'll at least be a little bit more convinced. And then, well, what if that doesn't make the bank happy? Well, then probably you find a full stack architecture consultant, maybe someone you meet at Python, and you hire them and they can tell you other ways to make the bank less unhappy. And if you want to see an example of this, take a look on GitHub. There's an example implementation of doing this in Nginx. Okay, so to summarize, the JWTs let you have this really nice distributed trust architecture. You can separate the authentication server from the application server and have the application servers just do the validation. Your application servers then they don't need secret keys. They can just have public keys. You need less security requirements. They're easier to maintain. You can give all your engineers access to the debug logs and so on. That's great. In general, JWTs are secure because they've got that cryptographic signature. They're efficient. They're relatively small. They're standardized, so you can use a lot of different programming languages and libraries. And you can manage your particular security architecture using Python decorators. Or you can use some libraries like PyJWT. That's the one I used in this example, in my examples. There's also a lot of other libraries you can use for Flask and Django. Or you can use a full-fledged authentication platform. You can use Auth0, Super Tokens, Cognito, Keycloak. Apologies to all the other platforms. I didn't have time to fit everything on there. So even if you never write any JWT code yourself, it's still helpful to know what's going on in a JWT, because then you understand a little bit why you have things that might look funny, like this refresh access token thing, why you have to be careful of the headers and so on. Okay, so that's the end of my talk. There's plenty of time for questions, so thank you very much for coming, and if you want to ask a question, please line up at the microphone. Sure, so here's the GitHub link. If you just go there, there'll be some documentation, some readmes. There's a link in the docs to the slides. There's some example Python code. It's relatively simple. One of the key features here is that if you want to do a simple security architecture, JWTs make it simple. If you want to do a complicated one, you can make it pretty sophisticated and complicated either yourself or using a platform. I think, do we have a question there at the microphone? Go ahead.
Yeah, so for a given access token, if we have state inside that token, which is no longer valid, how would you recommend refreshing that specific access token before it expires?
So let me repeat the question. So you're saying if you have state in the access token that's no longer valid, how do you deal with that?
Yeah, like, because, normally we'd request a new access token from the refresh token, but we don't do that until the access token expires. So, what's the recommended practice for forcing an access token refresh for everybody?
Right. So good question. So there's a lot of different ways to do it. What I would say is you should make your access tokens as short as possible. So 30 seconds, 15 seconds. So the idea is they're issued, they're used, and then they're no good anymore. So there's no concept really of revoking. Again, there's no way to really revoke an access token. They just expire. So what you don't want to do, and what you'll see some people do, is they'll have access tokens that last for, say, 10 minutes, and you use them over and over again. You can do it that way, but then you'll have the exact problem you're asking about, which is how do you revoke it? You can't. So ideally, you only want to let that access token live for a very short amount of time.
So I have a related question, but now about the refresh token. So can you talk a little bit about the secure ways to keep the refresh token stored securely? So in particular on like an SPA, I've just read things about, do you use local storage? Do you use cookies? Is one better than the other? And when you shouldn't use local storage because then like JavaScript can get it or whatever. So what's your recommendation for how to keep the refresh token secure?
That's a great question. I'm going to a little bit avoid answering your question and answer another question. So how do you keep the refresh token secure? Store it in a secure way with whatever system you're using. I can't really answer that because it's a little bit generic, but let me answer something that's related and important. So what you don't want to do is let the refresh token ever go anywhere except to the authentication server. So don't store it in plain text. Definitely don't send it to the application server, because one thing that's tempting is like, okay, this seems confusing. We've got two tokens. Like, why don't I just send the refresh token to the application server? Why don't I just pass the refresh token around anywhere? And the reason you don't want to do that is because the refresh token, if someone gets that, they can keep asking for access tokens and do whatever they want until you revoke it. So ideally, you only want the refresh token to go to the authentication server and back. And so you never want that exposed to anyone. You can use local storage, you can encrypt it, you can do whatever you like. Don't send it across the wire except to the authentication server. So I can talk to you after if you want more detailed questions. I think we probably have time for one more quick one.
Yeah, so in regards to refresh tokens, I've noticed a lot of mobile apps that use JWT, they stay open forever. Like you never log back in. It just seems like they're forever open. How do you do that with refresh tokens?
So I think what you're probably talking about is a long-lived refresh token. So one way you could write an app is you get a refresh token from the authentication server, and you get something that lasts for, say, a year, which I wouldn't necessarily recommend. And then if you don't somehow cancel that refresh token, your client app, your single-page web app, your phone, or whatever, whenever it wants to get some feature, some service from the application server, it's going to send that refresh token back to the authentication server. The whole purpose of the refresh token is the authentication server will not ask you for a login. It'll immediately send you back an access token. You'll use that access token to get service from the application server. So the best practice I would recommend is two things. One, don't make the refresh token last forever. Make it last for a day, a week, some reasonable time. And two, the other thing is you can provide a logout button or something like that. And what the logout button would do is it would delete the refresh token locally, but it would also go and tell the authentication server, hey, cancel this refresh token. Like make a note in your database or make a note for the user that they don't get any more access tokens, they need to get a new refresh token. I think we're out of time, but happy to talk more about this afterwards and offline, and feel free to put a message on the GitHub if you need it.